All right, let's do another lesson now. And this one should be way shorter than the previous one. And we're going to look at index to logs. All right, so what we're going to do, LOGS, what we're going to do is we're going to take the indices that we were working with just now, and we're going to look at how we convert them to logs. And the next lesson, we're going to start learning about logs. All right, so let me write the objective for this lesson. And I'm going to start writing with a little bit of a fat point. I kind of feeling like writing with a fat point right now. So objective, use the fact, you know what, let me stick to typing these out, right? Because it looks nice when I write, but let me type it out. So, there. So, index to logs, right? Put that in green, no blue. This is objective, and it's going to be use the fact that, well, we're going to have some kind of rule, and I'm just going to put a couple of spaces in between there, and I'll write the rule after, where, well, I'm going to have here a next rule here, and we're going to have a next rule there as well, right? Okay, so let's write this out. So we're going to use the fact that that a to the power of c equal to b can be converted into logs by this relationship. Base a and then b. You know what? Let me just write this out on a sentence. All right. Take this and this. Run it. Let's delete this. Right. Here's why I'm deleting it. I don't like how it's looking. Right. So let's do this, I guess. All right, the green will be objective. There's too much maths inside of it, and it'll take me too long to write it out, so that's why I'm doing this. Use the fact that a to the power of c equal to b can be changed to logs with the relationship log to the base of a, b equal to c. And you can take the logs and convert it back into index form, right? Now, your a, b, and your c have to be natural numbers, right? So where a, b, and c are members of the set of natural numbers, okay? And this case, b here has to be positive. So b must be greater than 0, right? B must be greater than 0. Okay, let's look at this, okay? So b has to be greater than 0. Oh, right, and another thing, a also has to be greater than 0. You know what? Let me just fix this up a little bit, right? Look, where a must be greater than 0. A cannot be equal to 1, right? A cannot be equal to 1, and b must be greater than 0. Yeah, those are the conditions that we're going to set for it. Okay, and again, this is just one little law here. And what I want to do now is I'm just going to take this little law here and I'm going to rewrite this, right? I'm going to put the a in yellow here and I'm going to put the a in yellow here so you can see where the numbers are going. Right, so you can see that c up here as the index goes to the other side of the equal sign. And then finally, well, let's put a color on it. And b, which is on the other side of the equal sign originally, is now going to be the number, log of that number. Okay, so notice where the various ones are going. Okay, notice where the various a, b, and c are going as they shift from one position to the next. Now, as you learn this, as you memorize this and learn this and how it works, this is an example of some of the problems you can use it to solve. So we're just going to go straight into examples, right? Straight into examples, because as long as you know this interchange here, that's it, right? Yeah, memorize that and we're going to solve some problems. Evaluate log to the base 4 of 1 over 64, okay? Log to the base 4 of 1 over 64. We're going to assume assume that x is equal to log to the base 4 of 1 over 64. That's the assumption that we make, right? And we're going to use the index relationship, using index log relationship. We can see right away that our 4, which is at the base here, right, that A can go up and become the base over here. So that's just going to be 4. And the other side of the equal sign, which is an x, remember the other side of the equal sign in this case is c, goes to the power. So we're going to have here goes to the x. And then we're going to have this number is going to be 1 over 64. And now it becomes easier to solve, because what we can do is we can say 4 4s are 16. 4 times 4 is going to be 16 times 4 is going to be 64. Yeah, 40 plus 24, 64. Right? So we're going to have 4 to the 1, 2, 3 power. Okay? So 4 to the x is equal to 1 over 4 to the third power. 4 to the x is going to be 4 to the minus 3 power. And therefore, from that, we can see that x is equal to negative 3. Hence, this up here, hence, log to the base 4 of 1 over 64 is going to be equal to negative 3. Okay? It's going to be equal to negative 3. No questions there, I'm pretty sure. So let's go straight on to the next example. Example 2. Right? We're going to solve 5 2x minus 1 equal to 7. And we're going to say to ourselves that we're given 5 2x minus 1 equals 7. We're going to use using the index log relationship. Using that relationship, we can see that, again, the base goes to the base of the log. So we're going to say log to the base 5. This 2x minus 1 goes to the other side. So we're going to have the 7 here and the 2x minus 1 over here. Right? And then what we do here, we simply make x the subject of the formula. So we're going to get that 2x is going to be equal to 1 plus log to the base 5 of 7. And then x is going to be equal to 1 plus log to the base 5 of 7 over 2. Now, most of the times that you get this, it's going to be in a log that you can actually work with very easily. It's going to be like log to the base e or log to the base 10. Right? And I'll tell you why. Because if you look on your calculator, and let me just pull up a calculator so you can see it here. If you look on the calculator, you can see a log's right over here. Right? You can see a log right over here. This is log to the base 10. Okay? That is log to the base 10. Okay? Most of the time, you're going to do that. Now, there's a change of base relationship, but they said to exclude that from your syllabus. So most of the time that they give it to you, it's going to be a log that you can actually type in on your calculator and work out very easily, right? It's just going to be log to the base 10 most of the time. I am, however, giving you these equations so that you can see exactly how you can use it to solve other problems as you move further on. When you get later on, you're going to do a change of base relationship, and that change of base relationship is going to help you solve this, because your calculator, and not many calculators, I should say, are able to actually do that. I'm looking at this one and I don't see it here. I'm only seeing the plain log, right? So you would use, in that case, you would use your change of base. Let me see if our next calculator has it. I have this log here, and no, I don't have it. Let's see my original calculator, not the software. And yes, my original calculator, not the software, has it, right? My original calculator, my original model of this calculator here has this relationship above the EXP button where you can set the base and you can set the value of the number. So you can say log to the base 5 of 7. Okay? I don't think they will give you it in CSEC, right? Let's continue from there. That's number 2. And yeah, that's number 2. Let's go to number 3. Okay, so this is going to be example number 3. Right? And for example number 3, what we want to do is we want to try and solve something a little bit more complicated. Let's say we're going to solve log to the base of x minus 1 to the power of 6, log of 16 there, and then you have 2. Okay, so we're given log of x minus 1, 16 equal to 2, and we're going to use the log index relationship. So we're going to using the index log relationship. What we can do is we can rewrite this in terms of powers. And we can see here we're going to get x minus 1, since it's the base, raised to the second power, since it's on the other side of the equal sign, is going to be equal to 16. Now, from here, we can just simply say that, oh, x minus 1 is going to be equal to the plus or minus square root of 16, which is going to be equal to plus or minus 4. That means we're going to get 2 values of x. Let's continue working and see what we get. So we're going to say that either x minus 1 is equal to positive 4, and you can just put that there, or x minus 1 is going to be equal to negative 4. And in this case, x would be equal to 5, and in this case, x would be equal to negative 3. Now, here's the condition. X cannot be negative, right? So let me write that out. But negative 3 minus 1 is equal to negative 4, right? Look at this, negative 4, okay? And since, now, from the time I get x minus 1 is equal to negative 4, I could have stopped here at that point and say that this is invalid, right? I could have stopped here and said that this is invalid, okay? I don't know why I keep writing that. Invalid. Yeah, I don't know, my handwriting is crappy right now. Anyway, so it's invalid, okay? So since the base x minus 1 must be greater than 0, minus 3 is invalid, right? And therefore, hence, the solution is x equal to 5, okay? With x equal to 5, we get a positive value, okay? Let's move on to number 3. I'll add a new page and start on the next one. This is number 3 or number 4? Oh, number 4. All right. So let's start with example number 4. Okay. So we're to solve 4x minus 2 equal to 30. And we're given, that's a problem. So given that 4 to the power of x minus 2 is equal to 30, using the index log relationship. Wow, lots of writing. Using the index log relationship, we're going to rewrite this and we're going to say, okay, well, 4 is the base. So we're going to have log to the base of 4. 30 is on the other side, so we're going to put 30 over here. And then this is going to be equal to x minus 2. And I'm going to just simply make x the subject of the formula by just simply adding 2 on both sides. And that means I'm going to get 2. Well, let me just put the x first. I like the x on my left-hand side. So x is going to be equal to 2 plus log to the base 4 of 30. Okay? And let's do another one. Last one, right? Last one. Example number 5. There's not going to need an exercise for this because that's it, right? Last one. Example number 5. Let's say 5 to the power of 2x minus 7 times 5 to the power of x plus 3 equals 0. Now this one I promise will be very complicated looking, okay? So that you can feel like, you know, you're solving something difficult. So given 5 to the power of 2x minus 7 dot 5 to the power of x plus 3 is equal to 0. What we're going to do is we're going to try and start rewriting this, right? We're going to rewrite this because if we rewrite it, what we're going to do is we're going to get it in terms of a quadratic. So we're going to rewrite, W-R-I-T-E. We're going to rewrite and we're going to get here 5 to the power of x to the second power minus 7 into 5 to the power of x plus 3 equals 0. And then from there, what I'm going to do is I'm going to say let x equal 5 to the power of x. And you should remember this from when we did reducible quadratic equations, right? we left this solution, this kind of equation incomplete. So let's complete it now so you know how to do it. So we get here, it's x, so we get here x squared minus 7x plus 3. So we're going to get here x squared minus 7x plus 3 equals 0. And from there we can say, using the quadratic equation, or quadratic formula with a equal to 1, b equal to -7, and c equal to 3, we're going to get a complicated looking thing that x, which is the variable I want to find, is going to be equal to negative of -7 plus or minus the square root of b squared. So -7 squared minus 4 into a into c, square root of that, right? All divided by 2 into 1. Okay, now that we have this really nasty looking thing, let's try and see if we can simplify it and solve it down a little bit. So I'll write fine point here. So this here is 7 to 49 here, and then this is 4 by -4, and -4 by 3, -12. So it's 49 minus 12, right? So that's 30 plus 7, so that's 37. So we're going to get here that, move back to my flat point, x is going to be equal to 7 plus or minus root of 37 all over 2. And that is going to be my x, right? But x is equal to 5 to the power of x. That means that my 5 to the power of x is going to be equal to my, well, let me just put it as this. So it's either 5 to the power of x is going to be equal to my 7 plus root of 37 over 2, or 5 to the power of x is going to be equal to 7 minus the root of 37 over 2. And then from there, we're going to see converting to log. So using the index log relationship, we can see right away that, oh, I need a new page. We can see right away that x is going to be equal to log to the base 5, yeah, because x is up here, right? So x goes on the other side of the equal sign, log base 5, and then we're going to have this here, this of 7 plus root of 37 over 2, was it? Yeah, 2. Right? And then close off the bracket there. Or x would be equal to log to the base 5 of 7, oopsie, base 5, not upper 5, base 5. Right, base 5 minus root of 37 all over 2. And that's it. Yeah, that's it for this lesson here. Now you know how to use the index log relationship to be able to convert your indices into logs so that you can just put it in on your calculator and solve it when you don't know the exponents, right? So when you're unsure of the exponents, you could use that relationship to find your exponents. Okay, so that's it for this lesson. And if you have any questions, comments, issues, and you want to let me know, let me know. I can see you in the next lesson. Enjoy the rest of your day.